Okay. Hello everybody, it's been a long time since I last did like a talking type video. So today I thought we'd talk about schematics for electronics, and then a little bit of math behind some electronics. So yeah, we'll get into the math in a little while later. Let's talk about schematics right now. So schematics are useful when you have a circuit board or any type of circuit. Having a schematic written down, it's a lot easier to assemble and also to troubleshoot. So you can't talk a schematic without basic components on your schematic. So anything like that, that's just, you know, any sort of connection. So solder on a PCB, even the traces on a PCB, anything like that. That's a, you know, or a wire or whatever, right? Another very simple component. This is a switch, sometimes represented as SW. Yeah, and then how about a power supply? So you can have different power supplies, say like this, and then this is an AC power supply, right? So AC doesn't matter the polarity; it's always it doesn't matter. So yeah, but you could have, you know, but you do have your live and neutral, and sometimes that does matter, but not very often. So VAC means volts AC, so you could have, you know, 15 volts AC, even 120, what comes out of the wall, right? How about a DC power supply? Well, we can do a couple different symbols here. One way you can represent that is you have a negative and a positive, right? This is sometimes referred to as ground. So what you might see on some schematics is something like that. That means reference to ground, which means negative on a DC power supply. So let's label that as ground, or GND. This is our positive, you know, and that can come out and do whatever. This is, you know, and then you would usually put like, you know, say 15 volts again, you know, or whatever, 12 volts. Doesn't matter. And then there's other super, like, you know, basic components, like a resistor. Resistor resists current. We can talk about that and when I get into math later. But, you know, a resistor can be represented like this. Or sometimes it'll be just represented like that, and then it'll, like, have R, you know, whatever. So yeah, this is a, you know, resistor is always represented as R on a PCB. So we could have R1, and then they have different values, and resistors are measured in ohms. So we could have 100 ohms, which is, then the symbol for ohms is omega, or the Greek letter O. So that's omega. That means resistance. Ohms of resistance. One of the other very, very simple components is the capacitor. So this is represented by C, so we could have like C, it's usually like, you know, C and then a number on a PCB. So yeah, and then capacitors are measured in farad, or named after Michael Faraday. Now that's something that I've always wondered, why was that, why is the measurement of capacitance named after Michael Faraday or farad, and why not, you know, something electromagnetic, which was Faraday's biggest discoveries? Instead, they named that after Tesla. It was just really weird. But anyway, so capacitors are measured in farad. Usually, you're not going to find anything that's like actual in the farad rating. Those are for supercapacitors, which you're not going to find in your average circuit. So you're usually going to see either it goes down pretty small. So you have picofarad, which is like really, really, really small. Then you have nanofarad, so NF, and then you have the most common that you're going to see on like electrolytic caps is UF, or microfarad. And then you can go up to, you know, you can get further up there. But yeah, let's see. capacitors. Then the diode, which LED, most people don't realize this stands for light emitting diode. So a diode on a schematic looks like this. And that means that, and then it's represented by a D. This means that it's, the arrow is pointing which way the diode is supposed to be going. Diodes are a one-way check valve, meaning that electricity can flow one way, but it can't flow back in the other direction. So they're often used to change AC from DC, because AC is alternating current and DC is direct current. So AC, the current changes back and forth 60 times a second in the US or 50 in Europe, which 60 times a second is pretty fast, or 60 hertz would be the correct way to say that, right? So that'll transform that into DC with a diode, or say a bridge rectifier, which means it's called a rectifier diode. But yeah, a bridge rectifier is 4 diodes in a specific arrangement, right? Let's see. Oh yes, and then the last one, which is sometimes represented as this, is the coil. And this is, so this is called an inductor, usually is the fancy term, but it's usually just a coil. And this is really interesting. This is represented as L, and so this is like L1. These are measured in something very interesting. It's called Henry. Usually small inductors you're going to measure not within Henry. It's going to be within like micro Henry, millihenry, yeah, whatever. Let's see, what else is there? One of the more complex components that you're probably not always going to see, but you might from time to time, schematic. Well, you're going to see these actually all the time, but they're kind of hard to understand. But they are a transistor. So I think I'm drawing this correctly, but this is called a BJT, or bipolar junction transistor, and they have a they're essentially switches, and so yeah, they do, but they can switch at very, very fast speeds. BJTs were developed in the 40s to get rid of vacuum tubes, so BJTs can still switch very fast, but there's more modern components like a MOSFET, which is metal oxide semiconductor field effect transistor, which it allows you to switch much faster and much more power than a BJT. So yeah, let's see, what else can we do here? What other components? Well, I mean, you can have an LED that's usually represented as something like this. These represent light, right? So this is LED 1, right? Diodes, LED is a form of diode. Diodes have drops across them, and drops across diodes mean that it's a voltage drop, so you're going to lose a little bit of voltage over the diode, which, you know, is just standard with most diodes. Let's see, what are some of the other basic components? Oh, one of my favorites that I use all the time. This consists of a coil, and then we have, what's the best way to draw this? A common terminal, and I'll just draw this as like what I usually use. This is called a relay, and sometimes it's represented as RLY. This is a relay, so this is also a switch, but it's controlled by this coil, which becomes an electromagnet and will pull the it'll pull the thing down. It'll pull the contacts over to switch the load, basically. Let's see, what else? Oh, transformer, which is something you'll see all the time to power things, which they've been replaced by switch mode power supplies, but switch mode power supplies still have transformers inside of them. And you'll still find transformers in higher demanding applications. I mean, they're used all the time to get power to your home. Yeah, so this is a transformer. And so this would be your primary winding and your secondary winding. Right. Primary is, you know, like your 120 volts, 240 volts, whatever goes in here. And then your secondary will either step that voltage down or step it up. And then it can be sent through a rectifier, which can transform that into DC. And then you can put a capacitor on the end to smooth that out a little bit better. There you go. Let's see, what else is there that's worth a note? Sometimes you'll have like a switch that's like a momentary switch. So this is not the proper way to do this, but I usually write this as just put an M below, and this is a momentary switch. So it's basically just a button that will, you know, you push it and it will close the circuit, and then it's spring loaded and it'll pop back up, and then it's, you know, no longer spring loaded. Well, then it's, the load isn't connected anymore. Yeah. Let's see, what am I forgetting? There are things that you'll see sometimes, like, especially on PCBs, you'll see things like this. This is called an integrated circuit, or IC. And ICs can do tons and tons of different things. They're all different. Some can be microcontrollers, which is a, you know, tiny computer. Most people know that. Some can be some can be for digital applications, some can be for analog applications, like the classic, like one of the first ever ICs ever made, and still very popular to this day, is the 555 timer chip, which is an analog timer, but it is very, very useful for different things. And it can switch, I think, as high as 1 megahertz, so 1 million times a second. Let's see, what else will you see? These are pretty much as basic as you're gonna get. If I think of something else, then I will show you. Now, let's draw an example of a circuit. So, we need our power supply. So, I'm gonna draw my power supply here. Now, circuit implies that it's circular, because in a circuit, the electricity must flow out and return. AC or DC, same thing. The electricity comes out and must return. So say, and I'm just going to draw a simple one right now. So say we've got our power source, this is plus, minus, and we'll say 9 volts, right? And then we'll just do, say, a simple light bulb here, so with a switch. This is a simple circuit. So we can do a light bulb. Let me see how well I can draw this in a short amount of time. There we go, light bulb. Right. You know, it doesn't matter because this is called a resistive load, so whether it's AC or DC, it does not matter what the what the resistive loads and inductive loads, usually AC or DC, it does not matter your polarity. But yeah, so I totally drew that backwards. This is usually, this point down here is usually an AC, that'd be your live lead, and this is your neutral. Or this would be your positive lead in a DC circuit, and this is your negative lead, but doesn't matter. But there we go. It returns. So now this is off right now, but we can totally take this and switch it over, right? We close the circuit, and then now our light bulb can turn on, right?